Hello everybody and welcome to the channel. If this is your first video with us, thank you so much for giving me a chance. And if you're someone who's well acquainted with my material and you're just circling back from like 2025 to see what my old stuff looked like, well check it out, I still had hair in 2022. I am Gentry, I am a computer science educator and researcher in Texas, and this is Starting Python with Machine Learning. Right, so who are you? That's me, who are you? This course is for really anyone who is interested in learning machine learning and doesn't have any knowledge of the Python programming language, right? So we're going to be learning both of these things together, right? The tool that is the Python programming language and the application that is machine learning, right? So you don't need to have a background in CS, computer science, to be watching this video, right? You don't need to have a background in programming, but it will really help you if you know some math already, right? And when I say math, I mean enough algebra to say like what is a function definition, right? A little bit of logic or discrete math would really help you. And it's going to be very important to be comfortable with like linear algebra and some matrix multiplications, because that's really the heart of machine learning, right? So this is something that interests me, right? A new way of teaching programming, right? Rather than learning programming as a sort of monolithic skill all by itself, right? First, pick the application, right? And then learn the language that fits the application, right? So if you're watching this video, it should be because you are someone who has heard about machine learning, who has heard about some of the cool stuff that's coming out now with machine learning and applications of it. And you want to try it out, and you want to learn the language that best drives that, right? And right now, Python is the best language to be learning if you are interested in machine learning, right? So the first thing I'm going to say to you as a student of any programming language, right, is pick a project. Find something that interests you. Find something that is going to bring you back every day to just do your little 20, 30, 60 minutes of coding, right? Because that's the way you're going to learn the skills. And at the end of it, you'll have a cool project, a phone application, or like a video game, or like a little bit of data analysis if you want to find a data set on Kaggle and start jumping into that and analyzing it a little bit, right? So we're going to let our focus on an application drive our focus on the language, right? So you're here to learn Python, and you're going to do that by learning machine learning. The focus of this video is going to be on the basics of the Python language, right? And what do I mean by basics? Well, that's going to be creating variables. So like, how do we store information in a computer in a way that's easily processed by the Python language? We're going to learn some simple operations, right? Some simple arithmetic operations that we can do to raw values. And when I say values, I mean like any bit of information we can express. A number, a word, a single character, right? That is a value. So anything we do to change those would be an operation. So if I say like 2 plus 2, right? That's two values that are serving as the operands, the inputs to one operation, addition, right? And we're also going to look at some simple I/O, is what a developer would say, a computer scientist would say, input, output, right? How do we get stuff into our computer? So how do we like ask our users to type a word? And how do we get some information back out to them, right? How do we like print the result of a big program that we've written? And here we are in my programming environment. This is what we call an integrated development environment, an IDE, right? And this one in particular is VS Code. Now, it's not really the focus of this video to install this piece of software, right? There's very good instructions on the internet already on how to set yourself up with VS Code, but I have installed the IDE. I have the Python 3 interpreter installed on this computer. Right now, there's a very good chance Python is already installed on your computer, depending on what operating system you're using. But you might need to go out and find that. depending on what you're using, right? So this is a Linux operating system, but if you're on Mac or Windows, right, it's not going to make a big difference, honestly, right? You can get to this place right here on any one of those three. So I have created a file, and I've ended it with the file extension .py, right? So that indicates that this is a Python file, right? And that means whatever I type in this window over here is going to be interpreted as Python code with an exception. Any line of code that starts with this, hashtag # octothorpe, whatever we call this little symbol right here, that's going to be a comment, right? So the Python interpreter is going to ignore that and only do the things that I type here, right? So if I try to build this and run this, I'm going to get an error, right? Because the interpreter knows that this is gibberish, right? So let's look at writing some code that isn't gibberish, right? And so I told you the first thing we're going to do in this video is store some values in some variables, right? A variable is a named location in the computer's memory where we can put stuff, whatever, numbers, words, lists of words, right? And a value is anything we would put into a variable, right? And Python makes this very easy. I'm going to use the assignment operator to store a value into a variable. The left-hand side of that assignment operator has to be the name of some variable, and the right-hand side is going to be whatever I want to put in there. So Python is going to look at this, right? It's going to say store the value 5 into the variable x. If I don't have an x in the program yet, Python's a friendly language. It's going to go ahead and make me a variable named x, right? So if I do the same thing and I store a 3 into my variable x, right? Now I'm not making a new video, or sorry, making a new variable. Instead, I'm updating the value stored in an old variable, right? So when this line of code runs, we get the value 5 stored into the variable x. If this program had output, we would see it down here in my terminal, but we haven't learned how to output anything yet. That's coming up later on, right? For now, I can store values in my variables. Something to look out for in Python, an easy thing to trip over, right? If I'm trying to count the number of students in my class, right? And I say, hey, I've got num students, there's 30 students in my class, right? And then I come back later and someone has dropped my class. I need to update the value stored in this variable. Num student equals 29. Right? Python is going to look at this second statement, and I hope you noticed this right away, right? Programming takes very careful attention to detail. I misspelled the name of my variable the second time. So now I do not have I do not have one variable, named num students. I have one named num students and one named num student, right? Python saw an unfamiliar name and has created a new variable for me, right? So this is something to look out for in the Python programming language, right? You need to be very careful about spelling with your variable names because you can unintentionally make new ones, right? So both of these variables are storing integer values, right? And since you have a little familiarity with math, y'all have taken some algebra, you know that an integer is a whole number, a number that doesn't end with a decimal, right? I can also store floating point values, which are those that have decimal places in them, right? I can store words, right? String values are what we call these as programmers. We call them strings because they're strings of characters. So I could put like the word hello into this variable named z. I can put what are called Boolean values, either true or false, into another one, right? So true with a capital T or false with a capital F. Either one of those are recognized values in the Python programming language. Right? And I can even explicitly tell Python that I don't want to store any value in a variable, but go ahead and make me a variable anyways, right? We could say like n equals none, capital N-O-N-E, none means no value. It means nothing, but this variable n still exists in memory. Something we can notice about all of these variables, I've got 6 variables in our program so far, is that each one of them stores only one value, right? We call these scalar values. Those of y'all that have taken some calculus or some physics, right, will hopefully recognize that word scalar as just referring to any variable that only holds one value, right? But we're not limited to just putting one value. Right? We're going to talk about 2 varieties of collections today, and I'm going to add another comment here just so we remember that these are scalar variables. Right? Python also provides us what are called collections, right? Variables that can hold more than one value in them. The first type of collection we want to look at is called a list. And I'm going to start giving these better names, right? We haven't talked about programming style at all yet. We're only a few minutes into our first video, right? But it's bad style as a programmer to use very simple names like this because it's easy to get confused when we're looking back at our code, right? Or when other people are reading our code. So what we really want to do, right, is give a variable a name that's going to tell us what type of variable it is. And what are we putting in there? This is just some random junk I'm coming up with, right? So, list of values is just going to be a list of some numbers I think of, 1, 2, 3, 4. I've enclosed them in square brackets, so Python will interpret list of values as a list, right? Python doesn't care what the name of this is. I could just make it V if I wanted to, right? List of values is just a way I'm using to communicate with myself as a programmer and with other programmers who might have to read my code. Maybe coworkers or maybe people who are interested in my project if I post it on the internet. So list of values is holding a list, and I can reference any position in that list using these square brackets again. List of values, square bracket. And confusingly, we're going to start counting from 0 in this case, right? So if I wanted to take this 1, which is the first value in my list, and I want to store it into this variable x, I would use my assignment operator to do that. X equals, right? Remember, the left-hand side of our assignment operator is the variable that gets the value. The right-hand side of the assignment operator is the value. What value do I want to get out of my list? I want to get the 0th one, right? A human being would probably say the first value. Computers don't think like us, right? And this changes from language to language. Some of y'all might have used computer languages in the past that start counting at 1. Python is not one of those languages. Python starts counting from 0. So this 0 is the first value in the list. The 1th value in the list would be the 2nd value, right? The 2th value in the list would be the 3rd. Right, so I want to take this 1, I want to take this 0 value out of my list and store it into X. Boom, we've done that. But that index is a little bit opaque, right? If I was storing, a list of car models in a parking lot, right? I might not have numbered the spaces 0, 1, 2, 3, 4, 5, 6, 7, right? So if I was like a valet trying to remember where I parked a bunch of cars, that would get very confusing very quickly. Wouldn't it be cool if instead of plugging in a numerical index like that, I could plug in a string index? So Python knows that you want to do that. Python, very friendly language, right? So Python has provided you a tool for doing that. It's called the dictionary, right? So if I want to create a dictionary of, what have I done? There we go, of values, right? So I can't just type out a list like this, right? For a list, every index is kind of fixed based on your position in the list. For a dictionary, every term needs a key, right? So let's say in space 1A, I have parked the blue, I don't know, Honda Civic. Honda, you can send those sponsorship bucks any minute you want, right? And then in space like 2C, I have parked, you know, the red Toyota Highlander. I don't know what model cars Toyota makes, but right now to retrieve these values out of the list, right? So our Z variable is holding strings, so let's store one of these strings into Z, and Python will let you change the data types of variables. There's no reason I have to put a string value into one of my string variables from up here, right? But just for consistency, I think it's good to avoid getting confused by maintaining, right, the data type of a variable. So let's get this first value out of dict of values, right? So I'm going to use the name of my collection again. I'm going to use square brackets again, right? And just like this 0 up here, I was telling Python, hey, go find me value 0. And Python said, oh, here's value 0. Now I'm going to plug in one of these keys, and Python is going to take that, right? So now key value 1A corresponds to the value Blue Honda Civic, right? Key 2C corresponds to the value red Toyota Highlander. So these are now collections, right? Dict of values and list of values are still variables in our program, but rather than holding one value, each one of them is holding multiple values. Let's start talking about some ways to change those values, right? Let's start talking about operations, right? And our operations, right? Among these, well, let's think about something, right? It's not going to be interesting if I say like x equals x plus 2, and now I run my program and I see nothing, right? This is kind of boring, isn't it? So before we really jump into talking about how to do arithmetic in our programs, let's learn a built-in function of the Python programming language, print. Whatever I put in these parentheses is going to be printed on my console down here when I run my program. So now if I build my program and I run my program, I see absolutely nothing. So, oh, sorry, I don't. There it is. It got lost in kind of the output of the interpreter here, which is telling me of, I'm sure, all sorts of helpful things. Right, but there's my hello printed on a line by itself right there. Right, so if I wanted hello to not be printed on a line by itself, I can pass in a keyword argument to this function, right? And I can say, hey, end every line that you print with like ellipses, ... And now we see hello ... and it's no longer on a line by itself, right? My prompt has popped up with right there on the same line, right? So arguments are the inputs of a function, right? Print is a function. We want to run this function, and we're telling it two things when we run it, right? The two things that we have told it are a nameless argument here, right? Just the string hello. We're saying, hey, print this string hello. But I know, because I've used Python for a while now, that the print function is also listening for some special keywords. End is the keyword that's going to tell this function what to print at the end of the line, right? Maybe not a new line character, maybe instead we're printing ellipses, right? So Python will take either raw arguments like hello here on the left, or keyword arguments here on the right. Keyword arguments have to start with a special word that the function is expecting already, right? And after that, we use the assignment operator to plug a value into that keyword operator. Okay, so I'm also not limited to only printing one value at a time, right? I can plug in as many as I want, and those values can either be literal values, right, which are like this string, a value that I have just typed, or like 1 would be an integer literal, right? This is a string literal, right? Here's a Boolean literal, just true, right? If I if I put in the name of a variable, right, Python's going to go fetch that value out of a variable, fetch some value out of a variable, and then dump that into my print statement for me, right? So if I want to see what's stored in all of my variables, x, num students, y, z, w, and n, I can pass all of these in as arguments to the print function. Some functions have a limited number of arguments that they can take, so you have to be careful when you're using functions that you're not familiar with. But I know that print can take as many as I feel like passing in. Right, so let's see x and y and z and num students, and you can see VS Code is very helpfully trying to fill some of these out for me. Right, so it recognizes the names of my variables and also some other common words that might be used in the programming language. Right, so now if I build this and I run this, I can see, right, 1 is stored in that x, a 3.0 is stored in this y, right? Z, we've assigned it the value blue Honda Civic, right? The string value blue Honda Civic. Num students is still at 30, right? And n is holding the value none, right? So, and that's something interesting to think about, right? N is not holding the string literal none, right? We didn't type the words none in here. It's holding the special reserved value in Python, none, which means no value at all. But it didn't print no value at all. It printed the words N-O-N-E, right? So Python, we can see here, if it gets a variable that it doesn't know how to print exactly, or right, that we might not know how to print if we were thinking about this like human beings, it can cast that value to a readable string, right? So casting means changing the data type of a value, right? So we can also do this to print, for instance, collections. If I want to see my list of values, I can put that in its own print statement. And what do we get here? Our list of values, right? And Python, while casting that list to a string value, has kept it enclosed in square brackets so that I, as the user, when I'm reading the output of my little terminal down here, know that it is a list and not just 1, 2, 3, 4 as like, I don't know, a string literal or something. Cool. So we can see what's going on in our variables now, right? We now have a tool for peeking into our computer's memory and seeing, hey, what value is stored at the special location named X? What value is stored at the location named num students? What value is stored at the location named Y? Which means now we can change those values in a meaningful way and see what happens, right? So X equals X plus 2, right? We might look at this as humans and be a little confused by this. What does X... Am I declaring that X is the same thing as 2 greater than X? Is the number 2 the same as the number 4? Right? We're not asserting the quality of this equality of this variable. We're assigning the quality of this variable, and we're going to resolve the right-hand side before we store it in the left-hand side, right? We've talked about this right-hand, left-hand with the assignment operator before. Right, so what we're going to do is going to go look, see, hey, what's in X? It's a 5. Now we have an arithmetic operation, right? An operation is any statement that is going to change the value of some variable, that is going to produce new values in Python, right? So addition is an operation. Operations take inputs that we call operands. So the inputs to the plus sign, to the addition operator, are X, which right now is holding the number 5, and 2, which is just the literal value 2. Right? So we resolve this. 5 plus 2, that's 7. We store that 7 in X, and let's make sure that that's worked. Print X, and I'm going to comment these out so we don't get our output too cluttered. Right? And what we're going to hope to see down here, and let's even put a little label on this, right? Let's be considerate of our users. So we're going to put a label on here. X is now 3. How did X get 3? Because we updated the value of X here. X is storing a 1. 1 plus 2 is 3. Store a 3 into X. Print the value here. X is now 3. Okay. What other arithmetic operators do we have access to in Python, right? Well, plus means that we must also have minus. If we want to multiply, right, we're going to use a star for that. That should be pretty familiar. Division, we have 2 different operators for division, either a single slash or a double slash. These are different operators in the Python language, and they behave slightly differently. So I'm going to print 2 divisions here, right? I'm going to divide the same numbers twice. 10 divided by 3. Print 10 divided by 3. Both of these operators, slash and slash slash, are the division operator. And if I run them here, this top one, 10 single divide by 3, gives us 3.3 repeating. 10 double divide by 3 gives us just the integer value 3. So that gives us kind of a clue as to what's different about these two, right? A single divide is going to do floating point division, right? It's going to return a floating point value, right? So the real number 10 divided by the real number 3 is 3.3 repeating, right? A double slash does integer division. And if you remember way back in elementary school, when you first learned how to do division like this, you probably would have said 10 divided by 3 is 3 remainder 1. So what we got here was the 3, the output of the integer division. How do we get the remainder? We're going to use the modulus operator for that, which is 1% sign, right? So we just said 10 integer division 3 is 3 remainder 1. So what we would hope to see from this operation, 10 mod 3, 10 modulus 3, programmers frequently abbreviate modulus as mod. We would hope to see the value 1 there, and there's our value 1. We have one more operator that you might not be familiar with, and it's a double multiply, right? And if we were very intelligent people who recognize patterns, we might look at single division sign, double division sign. This is floating point division and integer division. What, is this like floating point multiplication and this is integer multiplication? And no, integers are multiplied the same way, regardless of whether they are integers or floating point values. Print 10 exponent 3. A double multiply is an exponent. So 10 exponent 3, this is 10 to the power of 3. What we hope to see here is 1,000. And there it is. So these are our arithmetic operators. And I'm going to add modulus to our list here, just for anyone that's taking notes at home. The arithmetic operators are not the only ones in Python. Right? Another class of operators that we might be interested in are comparison operators. Right? We might want to know if one number is bigger than another one, right? Is x greater than 2? Something like that, right? So we've got greater than, we've got less than, we've got greater than or equals to, we've got less than or equals to, right? Exactly equals to is going to be written with 2 equal signs, right? A single equal sign is our assignment operator. It changes the value stored in variables. A double equal sign is a comparison for equality, right? It's going to return either a true or a false. It is true if both of its operands are the same thing, and it's false for any other situation. And not equals is just the opposite of that. All right? So let's print oh, I don't know, x equals 3, right? We know that that should be true. We still have our print statement going telling us that x is 3. So what we're going to see here when we run this, now below our 1,000, we should get a true. Okay, so that's equals to, how about x is less than 3, right? And I bet y'all can predict this, that we should expect to see false from this, right? Because 3 is not less than 3. So there's a true, there's a false. Very cool. So these are comparisons. Every comparison will be resolved as either a true or a false, right? That's what makes our comparison value, or our comparison operations, different from our arithmetic operations, right? Arithmetic operations do arithmetic. They return numerical values. Comparison operators do comparisons. They return Boolean values, right? And remember that Boolean is how we refer to true and false in programming languages, right? Named after the mathematician Boole, who proposed like a sort of algebra for working with true and false as numerical values, who was, he's really like a mind that computer science owes a ton to. So comparison operators compare numerical values, right? We can say like 3, right, like some variable is less than 3. We can also compare like string values, right? We can do lexicographic comparisons, right? So like cat is less than dog. I think we'll return, not the name dog, sorry, the string literal dog. Right, that is true because cat is earlier in the alphabet than dog is, right? But if we were to change this to like emu is less than dog, right, that should be false because emu is greater than dog in the alphabet, right? Emu is later than dog in the alphabet, right? So we can compare numerical or string values, but what about operations that act on those Boolean values, right? Is like true less than true, or is true greater than true? And that's a little philosophical for me, but we do actually have another class of operators that act on logical values, on Boolean values, right? We've got our logical operators, and, or, and not, right? So print. Let's just experiment to find this out, right? True or true. And right, so in Python, the Boolean values true and false have to be spelled with capital T's. Or the logical operators don't, though, right? I don't know why that decision was made that true and false have to be capital, or an and can't be capital. True or false. I'm getting a little error flag here, but that might just be left over. Oh, it's because that's not a comma. I need a comma there. Good. True or true, it's telling me is true. True or false, it's telling me is true. Because I neglected to change the value that we are ORing there. Okay, but true or false is still true. False or false now has become false, right? So, or is true if either operand is true. Now let's give this same experiment a try with the AND operator. Right? So false and false stays false. If I were to update one of these to a true, right? And remember, true or false is true. True and false here appears to be false. Right? So we're seeing that AND is behaving a little bit different than OR was. And so what we've kind of determined by brute forcing this problem, by trying a bunch of different combinations and recording our results, like true and proper scientists, right, is that AND is going to return true if both of its operands are true. Right? And we've been using literal values here, but I can also use, right, my variable values, right? So W is currently storing the value false. If I were to print W or true, false or true, right? Make a little prediction here in your head. What do you think we're going to see, right? I've got mine. I'm thinking of mine, right? I should write it down on a note card. But here we see true, right? W is storing false. We fetch the value out of that variable. False or true is true. If I change this to AND, right? And I'm not going to make us sit here and watch this run, but I think you would understand that this would be false, right? False and true is false, right? So we can string together our comparison operators using logical operators, right? So x is less than 3, that's a false, or y, and I'm using parentheses here to make the reading of this expression a little bit more natural. Then parentheses are not necessary. In order of operations, comparisons will be resolved before logical conjunctions. Right, but y is less than 1,000, right? So x is less than 3, that is false, because x is exactly 3. Y is less than 1,000, that is true. If we connect them together with an OR, we would expect to see another true printed down here. So this is kind of cool. Right? And logically, I think you could also see that lexicographic comparisons we could also string together, right? We can make these arbitrarily long, right? So if I want some more ands and ors in there, I can go really wild with them, right? And x equals 7, or w equals 92. Right, I can keep these going for as long as I want, right? But so far all we're seeing is values stored in our code, modified with arithmetic, compared with our comparison operators, and we can do a bunch of comparisons if we want to, right? Still a little bit boring, right? I think programs are more interesting, and I'm gonna comment out our old prints. Our output is starting to get a little cluttered down here, so I'm just going to comment these out for now. I think programs are a little bit more interesting if we can let our user input something, right? So I'm going to take some value, and I'm going to assign into it the return of a new function, input, right? So let's let me, the user, type something, and then let's print it right back on the screen. Gonna give this a build, give this a run. We still have some output hanging out here. And did our program crash? Has something terrible happened? But no, it is now quietly waiting for us to type something, right? It's gonna let me type until I hit the return sign. So I'm gonna type something weird. My dog is a fluffy dog. And when I hit return, we're going to store this string literal, right? This value is going to get stored into a variable named I. We're going to print the value stored in I. So what we should see when I hit return here is our same string printed back to us, right? And my terminal has gone back to the prompt, so our program has exited, right? Python programs don't need an explicit command to exit. If you want to tell them to exit explicitly, you can use the exit function, or it just quits running when it gets to the bottom of the file. Either one is fine. So this is kind of interesting, right? We can read in a string, and we can print a string. Let's see what happens if I try to do some simple arithmetic with some user input. I'm going to run this, right? And it's waiting for something. I want to do arithmetic, right? I want to print I plus 3, so I'm going to type a 7, and what we want to see as the output would be 10. And something's gone wrong, right? What I'm being told is that I cannot concatenate the input from the user, which is I, with the literal value 3, right? And what does concat? I told you to do addition. Why are you concatenating, right? These operations behave differently based on the data types of their operands, right? So plus does addition when we feed them integers or floats or whatever other kind of number you can think of. Concatenation just is a long word. It means smush together, right? So if we try to add two strings, instead of doing arithmetic addition, right, we're going to do concatenation, right? So if I do this like string style addition, and I actually don't want to comment out that line, let's leave that in, there we go. Right, I'm going to smush something new onto the end of it. Right, I'm going to, and that's, ooh, sorry, I smushed the enter sign. There we go. Let's get rid of all this. And that's for real. I still need to close out my function call, right? We need to terminate every set of parentheses, and I need to close out this string. Right, so in Python, strings can either be enclosed in double quotes or single quotes. There are stylistic distinctions between the two, but they're both strings. So I've chosen to use double quotes here. So now we're going to take whatever the user types and we're going to smush, and that's for real, onto the end of it. Right, so if I hunt down this print statement that I want to get rid of, and then I build this and I run this, right, we see a program not doing anything. It hasn't crashed. It's waiting for us. It's here. It went as far as line 55 and then very politely stopped and waited for us to type something, right? My dog is so fluffy. My dog is so fluffy, and that's for real. We've performed string concatenation, right? So we learned a new use for this operator, and we've also learned here that the return type of the input function is always going to be a string. If I don't want it to be a string, right, if I did want to figure out some way to make this work, I can explicitly cast this value. Now we've already seen a little bit of casting, right? We've seen casting when Python was doing it for us. That's called implicit casting. Explicit is when I do it for Python. When I say, hey, take this thing and cast it to this data type, right? So here, right, I'm treating this data type kind of like a function, right? It looks like a function call because it's followed by a set of parentheses like this, but the argument to this function is now another function, right? So how does Python know which function to run first? It's going to run the innermost function, take the return of that function, right? The output of that function, whatever that function gives back to us, and then use that as the input to this next function, right? So give this a build, give this a run, right? It hasn't crashed, it's just waiting for me. I'm going to type a 7, right? So what Python has done here, right, is return the string value 7. I typed a 7, input returned a 7, not as an integer, but as a string. I then cast that string to an integer. I can do that because 7 is an integer value, right? If I were to do something like typing, my dog is very fluffy, that's going to confuse Python. It doesn't know how to turn that into an integer, but it knows how to turn the character 7 into the number 7. So boom. Now this is working. That's kind of cool, right? Except my program is going to do the same thing every time. And that's kind of boring, right? Wouldn't it be cool if my program could respond to what I was doing and behave slightly differently? What if I let the user type a number and I want to either print, right, big number or small number, right? And let's arbitrarily say any number with 2 or more digits is big, right? How could we implement that? Well, that's called branching, right? We're saying to the program, either do this or do this, right? Never neither and never both, right? If we imagine ourselves walking down a path in the woods and that path splits off left and right in like classic Robert Frostian fashion, right? We have to either go left or go right. We can't do both, and we can't stop moving, right? The program has to continue terminating until it's finished or until it hits an error. So what would I say, right? I would say, like, if I is bigger than 10, if I is bigger than 10, then we're going to do this. And as a matter of fact, Python is a pretty well-written language. It understands this, right? This is exactly how Python phrases its branching, right? We're going to use the if keyword, right? If has to be followed by a condition. A condition is anything that is evaluated as either true or false, right? So we can use our comparison and logical operators to craft a condition that fits whatever behavior we're thinking about in our mind, right? And as a matter of fact, I've goofed a little right here, right? The number 10, when I is exactly equal to 10, we actually want to print big number. We've decided that any number with 2 or more digits is going to be a big number. Or else, we do this. Right? So listen to the way I phrase that. Or else we do this. Well, we can't use or. That's already a reserved keyword of the language. Right? So let's just use else. And now notice what I've done here. Right? I've got a block of code here that belongs in the if. I have a block of code here that belongs in the else. Right? But when I still had the indenting like this, you can see I'm getting a squiggle, right? I'm getting an error here. VS Code is very nicely telling me that I've done something syntactically incorrect, right? Because Python distinguishes blocks, right? Which means chunks of code using indentation. So I've jumped in by one tab here, and that's how Python knows that this print is inside of this if. This print is inside of this else, right? So let's give this a little build. Oh, right, and I've also done something very silly here, right? I is greater than 10 or I is equal to 10, right? What I mean here is I is greater than or equal to 10. Logically, these two statements are identical. They're going to behave exactly the same, right? If I replace this with I is greater than or equal to 10, mathematically, those two statements are exactly identical. But let's look at the way I had it written a second ago, right? Greater than is a comparison, equal to is a comparison, or is a logical operation. So even though they're mathematically equivalent, the way I've written it here is going to take more processing power in our program, right? Our computer has to do 3 operations instead of 1 operation, right? So anytime in your program you see several operations that can be replaced with a single operation, it's best to go ahead and take that opportunity, right? Now, is my program way faster? No, not noticeably. Operations in modern computers take tiny fractions of a second, right? So those 3 operations, we're talking about like 3 billionths of a second compared to 1 billionth of a second, right? It's not a span of time that a human being can notice, but it is good as a programmer to always be looking for little efficiencies in our program, right? So we're going to print either big number or small number. Let's give this a build. I'm going to type a 3, right? 3 only has a single digit, So we hope to see small number, and boom, there it is. Let's give this a build. Let's type a 100, and I've highlighted the wrong window. There we go. 100 has 3 digits, right? So we would hope to see big number. Boom, branching, right? Now, and actually I'm going to leave that in. Let's say we wanted to take that I and store it into X if it's a big number. But if it's a small number, we'll do nothing. Right? We're just going to print it. Sure, why not? Or equals 10. Here we go, right? Now we'll always have a big number stored in X no matter what, right? If I is greater than or equal to 10, we're going to store I into X. If I is not greater than or equal to 10, right? And the inversion of greater than or equal to is just less than, right? So we would say if X is less than 10, we're going to store a 10 into X, right? So if we give this a build and a run, it's going to be very boring because there's no more print statements. But I want to look at this code and think, right, like what if I wanted to shorten this down a little bit? And as a matter of fact, I can, right? Python will let me rewrite the same expression in line. We would call this, right? All on one line of code. X equals I if I is greater than or equal to 10, else 10. Right? We can rephrase if-else branching like this into a single line of code in this fashion. Now let's get rid of this. Let's get our nice print statements back. Right? And what if I want to add medium numbers to my program? What if instead of two-way branching, I was trying to do three-way branching, right? We're walking down our Robert Frostian path, and instead of splitting left and right, it goes left, right, or middle, right? So we might say if I is greater than 10, and then in the else, we could put another if I is greater than or equal to 5, right? That means this print is now a block inside of this else, but this else now is supposed to belong to this if, but we kind of broke it a little bit, right? So we're going to learn a new keyword right now, which is we just take the guts out of this else. Elif. The words else and if smushed together, right? So this means consider this condition first. If that condition is true, do this. If that condition is false, consider this condition. If this condition is true, do this. If that condition is false, right, then the else is like what happens if all of the elifs are false, right? Because I can include as many elifs as I want. And I also need to clean up my indentation a little bit there, right? Print smallish. There. So this is called branching, right? And this answers the very interesting question of, how do we make a program behave differently based on user input or based on the value of some variable, right? Now let's ask another interesting question. How do I do the same thing more than once? Right? Right? If I want to repeat some lines of code, I could just type them over and over again. Right? Let's do this like 3 times. I could copy it, and I could paste it, and now it's going to happen 3 times. But now, what if I want to keep doing this until the user guesses some secret number? Right? Until the user guesses 13. Right? I'm going to do this operation. I'm going to store some value in I. If, I is equal to secret number, then we can do some, congrats. We'll print congratulations on the screen. But now what the heck do we do? Right? If they're wrong, then we do this. But if they're right, we still go into this. Right? Kind of the problem we're running into is I don't know how many times to copy this statement. And I don't know how to skip these later ones if they're right the first time. Right? Except actually, I do know how to do this because it's the Python keyword while. And I'm going to steal these lines of code and I'm going to drop them down here below our comment block here to keep the kind of flow of this program going, right? And it's while, which is a loop, right? So now we're discussing looping in Python, right? So I'm going to put that back. There's a secret number and the user guesses a number. And we can say while they're wrong, right? For as long as the user still needs to keep guessing. So while I does not equal 13, or I don't want to hard code 13 there, I want to use my secret number variable, right? I'm going to print wrong, right? And then I'm going to take input again. It's very important to remember to take my input again, right? This loop depends on a variable. We call that the loop variable. So if I don't do anything to that variable inside of my loop, it never knows when to stop running, right? This loop is saying, while this condition is true, for as long as this condition is true, we're going to keep repeating this block of code. So if nothing happens to the variable I inside that block of code, our condition will always be true, right? We'll always keep running. And down here, I know that our user has broken this loop somehow. I know that our program has broken this loop somehow. The only way that our Python interpreter can be looking here at line 70 of this code is if this condition is false or has become false somehow. So this is where I want to put my congratulations message. Congratulations, you got it. Right? So let's run our program. We don't see any output. What's gone wrong? That's right. We're just waiting for our input again. Yeah. The secret number is 5. Oh, man, I was wrong. The secret number is 9. Oh, man, I was wrong. The secret number is 13. Hey, look, we got it. Because we got it, we exited our loop. We executed the next statement after our loop. So execution of our program was running statement, statement, statement. Get to the loop, check a condition. The condition was true because we're using not equals as our comparison, so 5 does not equal 13. Block, block, repeat the loop means check the condition. It was true, right? That means go into the loop, right? Block, block, repeat the loop, check the condition, right? Here we had typed at 13. 13 does not equal 13 is false. Break the loop. So execution of our program went here from 67, where it was doing this comparison, skips the loop. We do not enter the loop when the condition is false. We end up here on line 70. We print congratulations. Then we do our exit statement. We're done with the program. So this is a while loop. I can use it to repeat however many times, right, based on some user input. I can also use a special kind of loop to look at every value in a list, right? So for instance, we have list of values up here. List of values is currently storing 1, 2, 3, 4. The reserved keyword in Python for iterating over a list of values is for. I don't want to use I. By convention, we frequently use I as the loop variable for a for loop. I'll use J because why not? In list of values, right? That means we're going to pull values out of this list one at a time, right? First the 1, then the 2, then the 3, then the 4. A better way to think about it, first position 0, then position 1, then position 2, then position 3. We're going to, one at a time, store each one of them into this variable j. J is now, right? And I'm going to give 2 arguments to my print function. J is now, and then the value of j. I'm going to comment out our secret number guessing game program just to keep from cluttering up our terminal down here. And what we see, j is now 1, j is now 2, j is now 3, j is now 4, right? J has received each value from list of values one at a time, right? Starting with position 0. Right, so this was nice because list of values had some good counting numbers in it. What if I didn't have those numbers stored in a list, but I still wanted to get my good counting values going? Right? How could I do that? Right? There's another function in Python called range. Right? Range is going to give me a list of numbers starting at 0 and ending at whatever I type here. So if I type a 10 here, right, let's take a minute to predict the output of our program so that we know if it's working correctly or not. Right? J is going to first get a 0, then a 1, then a 2, then a 3, then a 4, right? So on, so up to 10. So good output for our program, the expected output of our program, J is now 1, or sorry, J is now 0, J is now 1, 2, 3, 4, 5, and I'm excluding the J is nows because I can only talk so fast and still be intelligible. But if we run it, right, Python is much faster than I can talk. So let's just see what it looks like. J is now 0, all the way up to J is now 9. So notice when we plug in a 10, J only went to 9, right? So this number is what we call an exclusive upper bound, right? We don't do this number. And as a matter of fact, range can take 2 arguments. If I give it 2 arguments, it's going to start here and end with this one, or actually end one before this one, right? So we start at 5, 6, 7, 8, 9. So our lower bound is inclusive. We start at this number. Our upper bound is exclusive, right? We stop one before this number, and I can actually give it 3 arguments if I want to. I can even plug in a step, right? So this now says start at 5, stop just before 10, and count by 2. So we should see J is now 5, 7, 9. That is all I have to say in this video. Thank you so much for stopping by. Expect another video on more complex Python operations coming at you in 2 weeks, I want to say. Right? If you want to catch that, go ahead and subscribe. If you like the video, press whatever button indicates that you have enjoyed watching this content. Presumably the like button if I'm putting these on YouTube, but you know, you do you. Do whatever feels natural. Again, I am Gentry, and I will see you in our next video for Advanced Python.